Good morning to all of you. Today we will do engineering mechanics. The subject name is engineering mechanics. Last class I had done 100 number of problems. I have completed 100 number of problems. Today I will discuss what is D-Alembert's principle. Then I'll do problems regarding this principle. This is a very important topic. D-Alembert's principle. Now D-Alembert's principle. This states that if a rigid body is acted upon by a system of forces, this states that if a rigid body is acted upon by a system of forces, and this system may be reduced to a single resultant force, then whose magnitude direction and line of action may be found out by the equations of dynamic equilibrium. This is known as D-Alembert's principle. The principle states that if a rigid body is acted upon by a system of forces and the system may be reduced to a single resultant force whose magnitude, direction and line of action may find out by the equation of dynamic equilibrium or graphic statistics. Then now I will tell you what is the equations. We know the force acting on a body, delta F is equal to ma. Clear? This equation 1. Or delta F minus ma is 0. This implies delta plus minus ma is equal to 0. Equation 2. Clear? The force minus ma is called accelerating force. or inertia force. Inertia force. Clear? So, what is accelerating force? M into A. Its magnitude is equal to product of mass and acceleration of the body and is acting opposite to the acceleration of the body. Clear? The magnitude of inertia force the magnitude of inertia force is equal to the product of mass and acceleration of the body. Acceleration of the body and ejecting and is acting opposite to the acceleration of the body. Right? Now, the force Ma is called inertia force. Its magnitude is equal to mass of the body and its acceleration, and is acting opposite to the acceleration of the body. Clear? So, in which direction the acceleration is acting? The acceleration is always acting in the motion of direction of the body, and the inertia force is acting opposite to the acceleration of the body. Clear? Now, delta plus minus m is 0. Clear? In the component form, delta of x plus minus m into x 0. Similarly, delta of y plus minus m into ay is 0. Clear? These equations are known as equations of dynamic equilibrium. And this concept is known as D-Alembert's principle. D-Alembert's principle. Clear? Along x direction, delta of x plus minus mx 0. Similarly, delta of y plus minus my 0. These two equations are known as equations of dynamic equilibrium. This concept is known as D-Alembert's principle. Clear? Now, I'll do some problems regarding this principle. Now I will do problems regarding this D-Alembert principle. This is question number 101. Last class I have completed 100 number of questions. Now this is question 101. The question is, an elevator of gross weight 1000 Newton starts to move upwards with a constant acceleration and acquires a velocity of 6 meter per second after traveling a distance of 6 meters. Find the tensile force T in the cable during the accelerated motion. Right? Now, this elevator, this is point A, this is point B. Point B. The elevator weighs 1000 Newton. This is weight double. Double is equal to 1000 Newton. Clear? The elevator gross weight 1000 Newton starts to move upwards with an acceleration, uniform acceleration, with a velocity of 6 meter per second after covering a distance of 6 meter. So at a u0, at a b is equal to 6 meter per second. The distance covered is 6 meter. 6 meter. Right? Find the tensile force T in the cable. This is tension T. What is weight is equal to 1000 Newton, u0, b 6 meter per second, distance covered from A to B is 6 meter. Find the tension T in the cable. Now, the T is equal to tension in the cable. In the cable. A uniform acceleration. A is equal to uniform acceleration. Uniform acceleration. Right? Now, for upward motion, what is v square is equal to u square minus plus 2s. So u0 c square is equal to 2 into a into s into 6. What is a is equal to 6 by 2 is equal to 3 meter per second square. This acceleration A. Acceleration A. Now the body moves downwards, the body moves upwards. So this acceleration A, it's opposite to MA. Right? So the acceleration is acting along the motion of the body, and MA is acting opposite to the motion of the body. Now, equating forces, T is equal to, this T is equal to MA plus W. MA plus W. So T is equal to MA WGA plus W. So T is equal to W into 1 plus A by G. Now put Put W is equal to 1000 Newton. A is equal to 3 meter per second square. And G is equal to 9.81 meter per second square or 10 meter per second square, right? It's better to put 10 because we are not using calculator, so I am putting G is equal to 10 meter per second square. Putting all the values, so T is equal to W 1000 into 1 plus A by G 3 by 10 is equal to 1000 into 1 plus 0.3. This is 1.3 into 1000. T is equal to, so T is equal to 1300 Newton. Great. Next. Now I will give you two number of notes which is applicable for this question. I will give two notes. Number one, note 1. One, the acceleration is always acting along the motion of the body. The acceleration is always acting along the motion of the body. Motion of the body. Number 2, the accelerating force MA the accelerating force MA is acting opposite to the direction of acceleration, right? The acceleration is acting along the motion of the body, and the accelerating force is acting opposite to the direction of acceleration. Suppose body is moving in this direction, then the acceleration is acting along this direction, but MA is acting opposite way. Similarly, suppose if friction is considered in the problem, then friction is always acting opposite to the motion of the body. Clear? Number 3. Number 3, suppose a body is here, weight W, a force P acting on the body, the normal action Rn. Clear? In this problem, the force acting towards right side. That means the body tries to move towards right side. So friction is acting opposite to the motion of the body. This is MA. This is F. What F is equal to? Mu Rn. Similarly, As the body moves towards right, so acceleration is acting toward the direction, and ma is acting opposite to the body. Right? This is horizontal plane. The body is resting here. Weight W, normal action Rn, applied force P. In this case, as the body moves towards right, so friction is acting towards left. That is opposite to the motion of the body. Again, the acceleration A is acting along the direction of the body. So the accelerating force Ma is acting opposite to the direction of the acceleration. Clear? This is horizontal plane. Suppose in inclined plane, suppose this is inclined plane, the weight W, weight is W. In this plane, suppose the force P is applied, then friction acting opposite to force. But here, no force acting on the body, only weight. This is suppose angle alpha, right? So in this case, the body tends to move downwards. So friction is acting upwards. F. What is F is equal to? URN. Right? The body tends to slide downwards. So friction is acting upwards. So what is Rn? This is x-axis. This is y-axis. Right? This is x-axis. This is y-axis. The plane is x-axis. The normal of the plane is y-axis. So suppose this is 90 degrees. What is this angle? 90 minus alpha. This angle is alpha. What is this force? W cos alpha. What is this force? W. Clear? This is normal action Rn. X-axis, y-axis. Now, in this problem, the body tried to move downwards, so acceleration is acting along the motion of the body, A. So opposite to that is Ma. This is figure for inclined plane. This is figure for horizontal plane. Clear? So we use these two figures for solving the next problems. Next problem number 102. Now, this is question number 102. The question is, the driver of an automobile travels along a straight level road highway, suddenly applies brakes so that the car slides for 2 seconds, covering a distance of 10 meters before coming to stop. Assume that during this time, the car moved with constant deceleration. Find the coefficient of friction between the tire and the pavement, means between the tire and a road surface. Suppose this car moves from A to B, moves from A to B. A, B, weight double. Normal action Rn at a its initial velocity b u at b is 0. The car stopped after covering distance of 10 meters. S is equal to 10 meter and t is equal to 2 seconds. Clear? The car slides for 2 seconds at a its velocity is u. He applies brakes at point A. Car moves from A to B. At B, the car comes to stop. That is B is equal to 0. And uniform deceleration during its motion. A is negative. Clear? Find the coefficient of friction between the car, tires of the car and the road surface. Suppose mu is coefficient of friction between the car, tires and the road surface. Now the car moves towards right, so this is acceleration A, this is ma. Again friction F. What is F is equal to URN. F is equal to URN. Given t is 2 seconds, s is 10 meter, v 0. Clear? What is mu? Mu is equal to coefficient of friction between the tire and pavement. And pavement. Right? So now B is equal to U plus AT. V0 or U is equal to minus AT. Again, what V square is equal to U square plus 2S. So 0 is equal to U square plus 2S. So 0 is equal to minus AT square 2S. U means AT. Clear? Minus AT. So 0 is equal to or minus 2S is equal to A square T square. What is A is equal to? Minus 2S by T square. 2S, what is S is equal to 10? Minus 2 into 10 by T square. 2 square. So 2, 5. A is equal to minus 5 meter per second square. This is value of A. Clear? Deceleration. So negative answer. Since the brakes, after applying brakes, the velocity come to stop. The body come to stop. So B is equal to 0. Hence, acceleration decreases and the value becomes negative. Now, what is Rn is double? What is Rn is equal to? W sigma y is equal to 0 W. Similarly, ma plus mu r is equal to 0. This side no force. Towards side no, there is no force, only left side force. ma plus sigma x is 0. ma plus mu r is equal to 0. What is ma? Double A Ga plus mu dot is Rn, double 0. Double cancel out. What is mu is equal to? Minus A by G. Minus A means minus 5 by G means 10. So 5 by 10, 0.5. What is mu is equal to? 0.5. Clear? This answer for mu. Now, in this question, the body moved towards right, so acceleration is acting towards right. In the opposite force, in the opposite direction, ma is acting. Again, body moves towards this side, right side, so friction F is mu Rn is acting towards left side. Again, so when equating sigma y, Rn is equal to W. Now along x, there is no force towards right side. A is not a force. So A cannot be added with ma or mu Rn. A is acceleration, A is not force. Only A shows the direction of the motion of the body. So we are equating ma plus mu Rn is equal to 0. So this side force, towards right side there is no force. So the answer is towards right side 0. So this plus this is 0. So from this we can find out mu is equal to 0.5. Clear? Next question number 103. Now, this is question number 103. The question is, a mine cage weighing 2000 Newton starts from rest and moves downwards with the constant acceleration A and traveling a distance of 100 meters in 10 seconds. Find the tensile force T in the cable during this time or during this motion. Suppose this is mine cage. The mine cage move from A to B. A to B. Clear? The mine cage weighs 2000 Newton. This is weight. This weight is equal to 2000 Newton. The mine cage moves from A to B. A to B. Starts from move from rest. U0. U is equal to 0. The tension T. The total distance S. This is velocity B. Clear? So time taken A to B T seconds. Uniform acceleration is A. The mine cage weights 2000 Newton, starts from rest U0, move downwards with constant acceleration. It covers a distance of 100 meters. S is 100 meters in 10 seconds. T is 10 seconds. Find the tensile force T in the cable during its motion or during this time. Now, the given question is weight W. What weight is equal to? 2000 Newton. T is equal to tension in the cable. In the cable. U0, S distance travel from A to B. S is equal to distance travel. What is S is equal to? 10 meter. T is equal to time taken. What T is equal to? 10 seconds. S is 100 meter. T is equal to 10 seconds. Right? So find the tension T in the cable. Now the body moves downwards. So this side acceleration. This is MA. Clear? The body moves downwards. So acceleration is acting along downward. MA is acting along upward. Clear? Now first find what is the acceleration. A is equal to acceleration of the cage. Acceleration of the cage. Now, what is S is equal to? Ut plus half at square. S. This is distance traveled by the body from A to B. So S means 100 is equal to, this is 0. U0, so this is 0. So 100 is equal to half A into 100 square. 10 square 100. Cancel out. What is A is equal to? 2 meter per second square. This acceleration acceleration A. Now T from figure T plus MA is equal to W. A 2 meter per second square. So T is equal to W minus MA. W minus W is G into A. So W into 1 minus A by G. Right? So T is equal to W. What W? 2000. 1 minus A by G. What is A? 2 by 10. So 2000 into 1 minus 0.2, 0.8. So 2000.8. T is equal to. So T is equal to 16,000 Newton, 0.8. So 8 by 10 means 1600 Newton. T is equal to 1600 Newton. This answer. Clear? Question number 4, 104. This is question number 104. The question is, an elevator weighing 1000 Newton is moving upward with uniform velocity of 12 meter per second. In what distance it will stop after the power is shut off? If the frictional force opposing motion is 20 Newton. Clear? So this elevator this weight weight W. So the elevator moves from A to B, A to B. At A is point B, so T0. After power shut off, the tension T is equal to 0. Right? At B, its velocity is V. So distance covered is S from A to B. And the body moves downwards, upwards. The elevator moves in the direction upwards. And the frictional force opposing motion is 20 Newton. This is frictional force F. What is F is equal to 20 Newton. Again, the body moves upwards, so acceleration is upwards and M is acting downwards. Right? This is question. An elevator weight in W, all means 1000 Newton. An elevator weighing 1000 Newton is moving upwards with uniform velocity of 12 meter per second. B. Clear? 12 meter per second. In what distance it will stop after power shut off? Means V is equal to 0. After power shut off means T is equal to 0. The frictional force opposite motion is F. What is F? This is F. F is equal to 20 Newton. Now, first write the given. This elevator weight W is 1000 Newton. Weight of elevator 1000 Newton. Clear? frictional force F is equal to 20 Newton. After power shut off, after power shut off, T is equal to 0. Clear? T is equal to 0. And U is equal to 12 meter per second. U is equal to initial velocity 12 meter per second. S, this S, distance travel from A to B. S is equal to distance traveled from A to B. A to B. Now, what is W is equal to W plus MA plus F0. W is acting downward, MA is acting downward, F is acting downwards. All three forces acting downwards, towards upwards T, but T is 0. Clear? Right? Equating forces MA plus W plus F is equal to T. Now T 0. What is MA? WGA plus W plus F is equal to 0. So W into 1 plus A by G plus F is 0. W is 1000. 1000 into 1 plus A by 10 plus F is 20 is equal to 0. Right? Now, one plus A by G is equal to minus 20 by 1000 minus 2 by 100. What is A by G is equal to minus 2 by 100 minus 1. So 100 into loss of LCM 100 minus 2 minus 100. Clear? So minus 102 by 100, 1.02. A by G is equal to, what is A is equal to 1.02 into G, meter per second square. Put G is equal to 10. So A is equal to A is equal to 1.02 into 10, 10.2 meter per second square. So A is equal to 10.2 meter per. Right? This acceleration A. And A is negative. So negative. A is equal to minus this. Minus this. So A is equal to minus 10.2 meter per second square. This acceleration A. Distance travel less. Now what is V square is equal to? Now V square is equal to U square plus 2S. This is 0. 0 is equal to U square. What is U? U. We use 12 meter per second. 12 square plus 2 into A. minus 10.2 into S. What is S is equal to? For 2 into 10.2 into S is equal to 12 square. The same place. What is S is equal to? 12 square by 2 into 10.2. So 12 into 12 by 2 into 10.2. S is equal to. So what is S is equal to? 7.05 meter. Sixty by 2, 6 and 12, 7.05 meter. This is distance traveled by the elevator after the power is shut off. Clear? Next question is 105. 10. This is question number 105. The question is, a small block of weight W is equal to 10 Newton is projected with initial velocity 30 meter per second along a horizontal plane and covers a distance of 100 meters before coming to rest. Find the coefficient of friction between the block and the plane. Coefficient of friction between the block and the plane. Clear? These are all problems from physics. Clear? These are all in physics. I will start physics on January 23. Clear? So this type of question also included in physics. These are all physics problem. The next problem. Now first draw the figure. You see block A, block B moves to B. The block moves from A to B. Clear? The weight of the block is 10 Newton. This is weight W. 10 Newton is projected horizontally with velocity U is equal to 30 meter per second. U. This is U. In a horizontal plane and cover distance S 100 meter before coming to stop. This is V. What V is equal to? 0 S. What is S? 100 meters. Find the coefficient of friction between the block and the plane. This is figure. Now I will explain what is U, what is V, what is mu. So this is U, S, B, time taken about T seconds. So this is double weight, so normal action RL. Again block moves towards right, so friction acting opposite to the motion of the body. This F. What F is equal to? Mu Rn. This is mu. What is mu is equal to? Coefficient of friction between the block and the road surface. Again block moves towards right, so this is acceleration A, this is Ma. Accelerating force Ma. Clear? First, find what is the acceleration. The block comes to stop, so V is equal to 0. So negative, we will find negative acceleration. Let A is equal to deceleration or acceleration of the body. Acceleration of the body. What is mu is equal to? Coefficient of friction. Coefficient of friction. Clear? Now B 0, S is equal to 100 meters. Weight W is equal to 100 Newton. Clear? 10 Newton, no, not 100, 10 Newton. Weight 10 Newton, S 100 meters, U, this is U, what U is equal to? 30 meter per second. U is equal to 30 meters initial velocity. First find out what is the acceleration, then find out what is mu, coefficient of friction. Now, this is figure. What is V square is equal to? Now V square is equation of motion. V square is equal to U square plus 2S. V 0. So 0 is equal to U square plus 2S. So 2S is equal to minus U square minus 30 into 30. What is A is equal to? Minus 30 into 30 by 2 dash. What is S is equal to? 100. 9 by 2 minus 4.5 minus 4.5 meter per second square. U is equal to minus 4.5 meter per second square. Now, what is R and W? And this plus this is 0. On right side there is no force. There is no force right side. This is acceleration. Acceleration cannot be added to this force. This is force, this is acceleration. A will not be added with the Ma and mu Rn. Now, sigma y 0. What is Rn is equal to? W. Similarly, Ma plus mu Rn is equal to 0. So double is into A, mu W is equal to 0. Double to cancel out. What is mu is equal to? Minus A by G minus of minus 4.5 by 10. So 4.5 by 10, 0.45. Clear? So mu is equal to 0.45. This is mu. This is class number 105. Next class I will do some problems in this chapter. then I will do new chapter. Clear? So please make like, share, subscribe to all our figures, all our videos. Thank you.